So moving on to look at instruments, I thought I'd start by just showing you the different colour coding of instruments that we have in surgical packs. So these are plain instruments, so they have no additional pigment on their handles, so we just have the normal metallic colour of the handle. So these are your bog standard surgical instruments of reasonable quality that you'll find the majority of instruments in standard surgical packs are composed of. So they're perfectly good quality instruments for surgery, but they're not a high quality instrument. For instruments which you need to make delicate cuts with, or instruments which have jaws which need to maintain a good grip, you can move up to higher quality instruments which are generally coloured with gold handles like this. So you can see that the handles of this instrument have got a gold pigment in them to separate them from the plain instruments. Now, gold-handled instruments generally are reserved for instruments which have an important cutting or holding function, and usually it indicates there has been enhancement of the cutting or gripping surface. So it may be that the cutting surface is more finely finished, so that it cuts more smoothly and more consistently, or it may be that the gripping surface is enhanced by the addition of additional metals or metal alloys to make a more hard-wearing and long-lasting gripping surface. And the last instrument that you'll occasionally encounter is this. So this is a black-handled instrument, and these are often referred to as being supercutting instruments, which tells you pretty much how it differs from these other two sets. So these are really quite expensive instruments. So you'll find most practices will have lots of plain instruments, and then particularly for needle holders and for finer dissecting scissors like Metzenbaum scissors that we'll look at in a minute, they'll have gold-handled instruments. But they're very unlikely to have black-handled or supercutting instruments, because really this level of quality exceeds what is necessary for most situations. So what the black handle actually means is that we have a precision engineered instrument, and that means that we have a very, very fine cutting surface, very sharp cutting surface. So we generally find them in instruments like this, which is a pair of scissors for cardiovascular surgery. So in the Smile Animal Hospital, we do have these, but we only have them in the packs that we use for cardiovascular surgery. So if you're looking to buy instruments, don't spend your money on a black-handled instrument. Silver or gold are what you want to focus on, unless you've got a specialist application. So we'll just come back and have a closer look at these gold-handled instruments that we've been looking at. These are a pair of needle holders, and we'll come on to look at needle holders in general in a little bit more detail next. But the reason these ones are gold is that if you look carefully at the jaws here, you can see you have the slightly darker metal on the gripping surface of the jaw here. And if you look carefully at them, you can actually see that the foot plate of this instrument has a little metal insert, which is made of a very strong alloy called tungsten carbide. And the reason that this is included in this instrument is to give it a very hard-wearing and very long-lasting gripping surface, which is very important for the smooth action of a needle holder. And the insertion of this alloy, the alloy is quite expensive. The engineering required to make the needle holder and then add in the insert adds to the complexity of the instrument and the cost of manufacture. So all of those things indicate an increased quality of instrument, and that's why this particular instrument is gold-handled. So an awful lot of the instruments that you'll see with gold-handled colouring, particularly the needle holders, will have tungsten carbide inserts at the tips, but it's not. But you do get gold-handled instruments which are just better engineered at the tips. So the presence or absence of tungsten carbide is slightly separate from the gold-handled, but for most gold-handled instruments and most gold-handled needle holders, they will be gold-handled because of the presence of tungsten carbide inserts at the cutting or holding tips. So we just come back and we'll look a little bit more at instruments and at needle holders. So I'm just going to start by telling you a little bit more about this particular conformation of instruments. So this is a needle holder, but this is a ring-handled needle holder. Now, ring-handled instruments, not surprisingly, have these rings at the end designed to take your fingers, like that, and that's where they get their name. They generally have a ratchet mechanism, but just behind the ring handles. The ratchet mechanism is quite critical, so when we're using a pair of needle holders, we want to grip onto the needle firmly with the tips of the needle holders, so we need to ensure that we engage one or two of the ratchets on the ratchet mechanism. So we come and look at some other elements that we've got of this. So we've got the ring handle, the ratchet, we have the shaft of the instrument, and then we come to the joint of the instrument, or the hinge of the instrument. So this particular type of instrument has a box lock hinge. So if I move it like that, you can see that we have this really robust joint between these two instruments where this shaft of the instrument has been inserted through a slit in this instrument shaft. So we have this kind of encaged joint which provides a very firm and secure joint. And then as we move from the joint, the box lock joint here, down, we have the jaws of the instrument which come down to the tip. So we've got two basic forms of needle holder, one of which you will see in the Hospital of Small Animals and one of which you won't. So I had to go and dig in the archives for one of these. So this is the one that you may be familiar with from seeing practice. This is a Gilly needle holder. Now, Gilly needle holders are very specifically designed needle holders, designed to enable you to hold needles and to cut suture at the same time. But you'll notice they have a very strange conformation of handle here, and critically, they have no ratchet mechanism. So it's actually very difficult to firmly grasp a needle with a pair of Gilly needle holders. And if you can't grasp a needle firmly, then it means that you can't control it accurately. So we don't use Gilly needle holders, and we will discourage you from using them. So the needle holders that we have as our standard are these, and these are called Mayo Hager needle holders. So as we've already seen, these are ratcheted, ring-handled needle holders. They have this very secure box lock. They have no scissor along their blade, so you can't cut suture at with the same instrument as you use to place the needle through the tissues. But they have a very good ratchet mechanism and a very secure jaw for gripping the needle, and for those reasons they're our preferred needle holder in the clinic. Okay, so I'm just going to show you how to load a needle onto a pair of needle holders. So this is a kind of fairly standard surgical needle we've got here. This is swaged on, so the suture material inserts into a little channel at the back of the needle. We have the needle coming along here with a nice arc on it. Now, needle holders are designed to be used with curved needles like this, not with straight needles. We have the cutting tip of the needle here. So when we're picking up a needle, we want to ensure that we don't damage the cutting tip. So we're going to want to hold the needle somewhere between the midpoint and the suture material, somewhere along this sort of caudal half of the needle, so that we're well away from the tip. We're not going to damage its ability to go through tissues, but so that we've got good control over it. So we'll come in there, we'll grip that firmly, like that. Okay, so that's pretty good. We're about a third of the way from the suture material along the shaft, staying well away from the cutting tip of the needle there. So I've loaded a needle onto this needle holder. Now there's a classic grip which you must use to manipulate ring-handled instruments. So I'm going to place my third finger in the lower ring handle, my thumb in the top ring handle, and my index finger is going to extend along the shaft of the instrument. Now, with your middle finger, I usually just pop that underneath the lower shaft, just to keep it out of the way and to give me a little bit more control. You'll notice as I'm doing this, I'm holding these ring handles on the first knuckle of each finger. I'm not taking it right into my palm like this. And I'm trying to end up with what is called a tripod grip. So I want 3 good points of contact. So I've got one here, and one here. Now, the whole point of using a needle holder with a curved needle is to be able to take your hand through these kind of pronation and supination movements. So if you then take a patient or a skin pad, as we've got here, you can move that needle easily through the tissues in a nice fluid movement like that. So in order to do that, it is critical that you hold the needle, as we've shown you, in that point between halfway along and the end of the shaft next to the suture material, then that you have that tripod grip, because that gives you really good fine control. It really maximizes the ability of you to pronate and supinate your arm in order to take the needle through that arc of movement, which is going to pass it through the tissues in a nice controlled fashion. So just remember, first knuckles only, index finger extended along the shaft, third finger in the bottom, thumb in the top ring handle, index finger along the shaft, middle finger you can just pop on the bottom of the lower shaft just for a little bit of stability. Pinky, tuck it out of the way, you don't need that for surgery. So I've been disparaging of the Gilly needle holder, so I'll now demonstrate why. The Gilly needle holder is designed for a slightly different grip. So we're going to hold the Gilly needle holder, third finger in the bottom shaft, thumb in the top shaft, index finger along. The way it is designed, it kind of encourages you to take the needle into the palm of your hand, and it's actually very difficult to really hold it with a good tripod grip. And one of the things about that is, because there's no ratchet here with a Gilly needle holder, in order to keep this needle securely in the tips, I need to apply constant and consistent downward pressure. So I need to concentrate hard on squeezing my thumb ring handle and the lower ring handle together so that this needle is held firmly. And if you look, I'm applying a lot of pressure there, and I can still move the needle relatively easily. So the problem with that is you spend really quite a lot of effort maintaining the needle in position, and it makes your movements a little clunkier and a little bit more difficult. So although you may see this more often, it's much better just to move on to a ratcheted ring-handled instrument like this, which is really designed to give you good control with a tripod grip. And if you grip properly, you've got a very, very firm, secure needle. So all that I need to do now is to focus on movement. I don't really need to expend any energy gripping the needle because of the ratchet. And although that sounds a bit pathetic, if you think about it, if you're spending time with all your muscles gripping firmly the needle with a needle holder, you're going to have much less control over the fine movement of your hand. And the final thing, just when we're doing this sort of general introduction to instruments, is that for ratcheted instruments like this and for scissors, there is a left and a right-handed version of each instrument. Now, I'm afraid we generally just have right-handed instruments in the clinic. We do have a few left-handed, but not very, very many. And it is quite important, if you're a left-handed surgeon, that you appreciate the difference between these, because for both scissors and for ratchet instruments like this, the way that you open and close the instrument is to open this instrument from the ratchet, I'm going to push away with my thumb and pull in with my finger. like that. If I try and do that with my left hand, then I can't physically do that because the ratchet prevents me from pushing my thumb away. And the way that I'd have to open it, which is much more difficult, is to pull towards me with my thumb and push away with my lower finger. So if you do find yourself using the wrong handed instrument for your preference, then you do have difficulty. And with scissors, which I'm sure people who are left-handed will already appreciate, the cutting action of scissors also relies a little bit on you pushing away with your thumb, and that pushes the blade controlled by your thumb up against the other blade, and that's what gives you the nice cutting action. So if you try and do that, if you try and cut with a pair of right-handed scissors with your left hand, you're far less likely to get a good cut. And you can do that just with a pair of household scissors and a sheet of paper and see what the difference is between cutting. So this is a supersized pair of Mayer Hager needle holders, just to show you what the foot plate of the Mayer Hager needle holder looks like. So most needle holders have a conformation of foot plate which looks like this. So if you look carefully, you can see these crossed striations providing quite a rough surface if you run your finger along that. And we have all these little square pegs really, or teeth, or ridges, which give you the gripping action of the Mayer Hager needle holder. So that's very good for holding the circular shaft of the needle. The other thing that we can see here nicely is you can see that the jaw is composed of two different types of metal. We've got this classic surgical steel forming up the bulk of the jaw and extending along the shaft to the handle. You can see we've got this darker grey insert here. You can just see the edge of it running along there, and a little groove that's been cut within this stainless steel jaw to accommodate this. So this is a tungsten carbide insert. So you can see it's about 1 millimeter thick. It just forms the foot plate where those cross striations are to give us that gripping surface. And tungsten carbide is a very hard-wearing alloy. So this markedly extends the life of the instrument because we'll maintain this nice rough surface for holding needles for a much longer period of time. And another supersized set of needle holders here, just for you to see. You can see this is a cheaper set of instruments without a tungsten carbide insert. You can see we've just got one form of metal forming the entire jaw. And these ones don't even have the cross striations. These have just a fairly simple pattern along their jaw. But I just wanted to demonstrate a simpler instrument. So if we look at the handles, we'll recognize that the ones with tungsten carbide, higher quality, so they tend to be color-coded gold, whereas the ones with the without the tungsten carbide inserts tend to be plain. However, the presence of tungsten carbide alone will not give you a gold coloration. You can get this with instruments just of higher quality in general, but for most of the ones which have a needle holding foot plate, so most of the needle holders with this will have a tungsten carbide insert, and that's what will push them up into that higher quality brand of instrument.